Hello, we are Group 18. I'm going to talk about our Kaggle competition. This is our outline. Firstly, after we read the data file, we convert categorical variables in train dataset to appropriate types. As you see, we change the category names and training data cleaning. Then we try to identify the outliers and then remove them. We use ROC curves to test the accuracy of our logistic regression model. The ROC curves plot the TPR vs FPR at different thresholds. And the higher the score, the better the performance. So 10 times cross-validation is performed to estimate the performance of our model more accurately. This is a logistic regression model we built. The code uses a binomial family to fit the model and displays a summary of the output, including coefficients and p-values. We also build a random forest model that uses variables other than school to predict returns. The random forest model is used to predict the probability of the binary outcome variable on the test dataset. The predictions are then combined with the school column in the test to create a new data frame called pretest. The algorithm builds multiple decision trees and outputs the patterns for each tree class. Entry parameter we set is 750, node size is 3, and M-tree is 12. To prepare the predict probabilities for submission, we need to modify the structure of the pretest data frame. The first step is to rename the second column from not to went on backorder. This is likely done because the original column name was lost during some operation and needs to be restored for clarity. Next, we need to remove the unnamed variables from the pretest data box. This step is important because unnamed variables can cause problems during the file writing process. We then write the modified pretest data frame to a CSV file called submission.csv without the line names. This file is then ready for submission in order to evaluate and score the performance of the model. The data being analyzed is very unbalanced, and the target variables are highly correlated with some of the predictor variables. Noise in the data may affect the ability of the model to make accurate predictions. Cook's distance is used to identify influential observations in linear regression models. But determining a cutoff value can be challenging. Other methods, such as feature selection, regularization, cross-validation, or outlier detection, can be used to improve the accuracy of the model. At last, we found random forest model is better than logistic regression. Random forest is a robust algorithm that processes data well and supports feature selection and anomaly detection. In addition, the dataset we used in building the random forest model is extremely imbalanced and skewed. So the averaging data is misleading due to the outliers, which significantly impact the average and provide an unreliable representation of the trend. Similarly, mean is also sensitive to outliers. Altering it and reducing its effectiveness in reflecting the trend. However, due to random forest's excellent ability of handling noise in data, our model of random forest can achieve high accuracy. Moreover, we have set the random forest model tree number to be around half of the data size. Because in general, the higher the number of the trees, the higher the accuracy, and the trees number around 700 gives the best accuracy result. Also, we specify the M-tree argument to be 9, which means the model will take 9 random variables from the dataset and examine them for one tree. The reason we use M-tree to be 9 is because after we checked the collinearity of independent variables in the data, 9 to 13 will be the approximate number of real relevant variables. Thank you for watching our group's video.